Okay, this video is going to talk about streams. Streams are a special kind of way to manipulate collections of objects. So the best way to illustrate this is with an example. So let's take this class. For example, this is the class dish. My class dish has a name, a type, whether it's vegetarian, poultry, pasta, whatever, an integer calories, right? So these are the three member variables. It has a boolean is vegetarian. This will return true if the type equals vegetarian. Now, it has a constructor where I pass the name, the calories, and the type, and they set these member variables up here, right, with this. And I override the toString method to return the name, the calories, and it is whatever, vegetarian, poultry, whatever. So I have a dish class that stores the name, the type, and the calories of objects and can tell you whether they're vegetarian or not. All right. So what we're going to do now is, let's say I have another class here, public class stream versus collections. That's what I've called it because I'm going to illustrate how to do something in the way that we know without streams, and then how the same kind of operations could be done with streams. So let's say we have a menu, which is basically an array list of dishes, right? Of dish objects. And I'm going to add this 5 items in the menu, these 5 dishes. So the first one, I'm going to add a new dish, Bandunjan, with 340 calories, and that's vegetarian. Then I'm going to add a house salad with 150 calories, and that's vegetarian, and so on and so forth, right? And some are poultry, some are seafood, and 3 of these are vegetarian. Now notice that this one has 450, 350, and 150 calories. So we have high calorie and lower calorie here. Now, what I also created is this public static method, just so I can call it, select veggie v1, and I'm going to pass the menu. Okay, and what I'm going to do here is I'm going to try to select those high calorie vegetarian plates, and I'm going to append the string high calorie to their name. So I will create a temporary list, menu2, right? That's going to be an array list. And here, for each dish in the menu that was passed to me, for each dish in the menu, I'm going to ask, well, if it's vegetarian and if the calories are above 200, I could have done this with an and, but I just wanted to give you step by step. So if the dish is vegetarian and the calories are above 200, then I'm going to change the name to high calorie and whatever the name is, right? So high calorie house salad, or high calorie Bandunjan, right? Now, and then I'm going to add it to menu 2. Why do I do this? Well, I wanted a separate list. I didn't want to eliminate items in the original menu list. That's why I created a temporary list. And then what I'm going to do is I'm going to call the toString method on the list, which in turn will call the toString method on each one of the menu items. So let's uncomment this line. Let's save and compile this. And let's run it. Here I have high calorie Bandunjan, that's 340, and it is vegetarian. And then high calorie lentil soup, which is 450, and it is vegetarian. So I effectively filtered the high calorie vegetarian, this one and this one. Okay? This is what I would do with a collection. Now, perhaps a side effect that I don't want here is that although I'm storing them in a separate list, the items names for these 2 have changed in the original list as well because I changed the object's name. Okay? But this is how maybe I would want to do this. Now, let's think of another way to do this that actually uses streams. Streams are a way to read elements from a collection and put them in a pipeline of things to do with those elements one by one. Okay? So imagine a pantry versus the supermarket cashier. In a pantry, you have all the items, just like in a collection. And you can ask in the pantry, okay, what's the third item? What's the third item from the left, right? You can ask those questions. In the supermarket, you don't know what order the cashier is going to process your item, so you cannot say, hey, what's the 10th element you're going to process? The cashier doesn't know. She just gets the elements and processes it, right? The streams are like that. It's like you're getting elements one at a time, and then you're putting them all through a pipeline. So let's try to do this with streams. So I created a new select veggie v2 method that, for simplicity, I'm just going to collapse this. I'm going to show here. Again, select veggie v2 creates a list menu. Now with the menu, I'm going to convert that to a stream. Please watch the video on concatenating methods and you will understand what follows next. But first, the menu, I'm going to convert it to a stream. So the list objects have a method called stream that converts them to a stream object. And with the stream, I'm going to call a filter, and I'm going to say filter on, and then here, the best practice is to use lambda expressions. So if you do not know what lambda expressions are, please watch that video. But here, I'm going to put dish is vegetarian. So the first filter, I'm going to filter all the ones that are vegetarian. Then I'm going to filter all the ones with calories above 200. And then I'm going to map, meaning I'm going to change elements. I'm going to say the element of the list, it's going to be high calorie plus whatever the name of the dish is. Okay, so this D is the dish that comes into the map function. And then what I'm going to do is I'm going to call collect, okay, which means all these elements that you filter, convert them to a list of elements. And then just call, because you convert them to a list of elements to a list object, then just call the toString method on that list. Okay? I'm going to explain this later a little bit more, but let's see how this one works. So I'm going to compile this and run it. And we get the same thing, high calorie bamdamjan, high calorie lentil soup. Okay? So, plus name, yeah, a collection to list. Perfect. Now, another thing that I can that is important to remark here is that here I have created a separate list. I have not changed the main elements on the original menu list. Okay, I create a separate list. The other thing that's important to understand here is that if we open both versions of the methods, right? If you're doing complex operations on a list, or even simple operations on a list, there's quite the overhead of curly braces, if statements. If statements can be very complicated at times, and if I nest them, they can be very complicated, and so on and so forth. However, if I use streams, I just use an order set of filters. So filter, one filter, then filter based on some other criteria, then map, which means convert the elements onto something else. So convert the name onto high calorie and that name. And then at the end of this pipeline, I will collect everything that passed these filters and went through this map. I will collect them and I will convert them to a separate list. And then I'm going to call the toString method on that list. So what effectively streams are doing here, it's a different way of processing the same list. Both ways are very similar, but there's some differences, right? I believe streams allow for more readability, and we're going to see how streams also work in a way that's called lazy. So let's look at that. So a collection is like a DVD. You load the whole DVD in the computer and then you can search, seek, and open a movie and close a movie and do whatever you want. A stream is more like a movie stream from the internet. Pieces come and then you do something with those pieces and then you spit them out, right? It's a little bit like that. So streams actually have a source of the data, Then there's intermediate operations, those filters that I used, right? And then there's an output from the operation. So intermediate operations use lazy evaluation, meaning the intermediate operations will evaluate one item at a time. They're not going to load the whole stream in memory and then operate like a collection would, right? Now, those are the main differences from stream and collections. Now, let's look at building streams, right? So how can I build streams? I've created a little class building streams just so that you get an idea. So for example, I can have a stream. By the way, you have to import Java util stream, and for collectors, Java util stream collectors, and then there's other imports if you want to get more advanced with streams. But for example, here I create a stream random, okay? And here's how I can build a stream. Stream.generate, and then I call the math.random function, right? So I can generate randoms. Now with these streams, I can call one of those termination methods that we talked about, one of the terminal operations called for each, which means that's going to go for each one that is generated. For each element, it's just going to print it, right? And we can see that this will compile and run, and you will see that it's going to start printing random numbers until I stop. This stream that never stops, okay? So it's infinite, okay? So there's infinity of elements. So if I want to, for example, what I can do with streams like this is instead of randoms, I can say that limit the first 100 elements, and then I call the for each, right? Now, if I want to be more concise, I can do it like this, right? So random limit 100 and then for each. And I compile this and execute, and this will return 100. Sorry, there were 100, that's why. So as you can see, we can infinite streams can be useful if we want to get, the first 10, 100 random numbers. I can create another one of those infinite streams, right, with the iterate method. The iterate method takes a seed, let's say start from 0, and a lambda, right, let's say n plus 2. That means that's going to get me from 0, it's going to be counting 2s, 2, 4, 6, so all the even numbers, and I'm going to limit to 10, and let's see how this does. Oh, and this, because these are integers, I'm just going to say this is a stream of integers. Let's compile it and run it. And this should print the first 100 even numbers. Now, I can also create streams from some object. I'm not going to limit them anymore. I cannot do the intermediate operations. That's fine. The source and the terminal operations are a must. The intermediate operations are optional. So in a stream, for example, I can also do this. I can say stream off, and then I can put any kind of a series of objects. So A, B, C, D, for example, right? And that's going to create a stream of, with A, B, C, and D together, right? Now, whoops. This is randoms, I forgot the name. So I can compile it and run it. This is strings. A little bit of data type errors that you might also have, so it might be useful to see them. And it goes like that, A, B, C, D. Now, another interesting thing is that streams can also, if you have a list, like an array list, like I did in my stream versus collection class, if I have an array list, or any kind of list, any kind of collection really, I can call the stream method with them, okay? I can create also empty streams and so on and so forth. The other stream that's really important that I'm not going to show here, but is creating a stream from a file. And these are very useful because really, when you have 5 objects, why do you need a stream? I mean, both of these methods are fairly clear. But when you have data that is coming, say, from a database or from a file, right? And it's a lot of data, you want to process it as a stream. The advantage is that a stream, because it's just a pipeline of objects, it's way more efficient in memory most of the time, not always, but most of the time is way more efficient in memory. And it also allows for parallelism, because none of the next object does not depend on the previous object, right? So whatever happens to this filter whatever happened to this filter to whatever element, it doesn't need to know about the next element or the previous element or any other element. In here, for example, right, this is in a menu. I need to have the whole menu in memory, okay, to be able to do this. And I'm actually doing a for loop that is basically iterating through the items here, but I could, if I wanted, change other items in the menu, change the third, the fourth, the fifth item in the menu randomly, right, or arbitrarily. Here with streams, I cannot. I can only change, or I can only do something on the item that it's provided to me by the stream, one at a time, and then I forget about it. So reading files, filtering, selecting data, cross-referencing data with streams is much more efficient, and it can be done in parallel. There are 2 stream operations that do not follow this, and those are distinct and sorted. You can sort a stream, or you can select distinct element in the stream. Those 2 might need to store an additional list to do the temporary sorting or the temporary distinction, and they will store however much memory they need to actually do those operations. So some distincts, it might be pretty easy. It might be, you have only one repetition and it only stores one element. And some sorting, it might be that the data is, almost sorted and there's nothing to do. So, but this is basically streams, right? This is basically stream. It's a way to process collections of things in a way that makes sense like this. And you have 2 operations that are key, right? You can map and you can reduce. You can basically do something with the whole collection and reduce it. So for example, you could actually, instead of collect, you could sum. You could add all the elements if these were strings. Another proper reduction on streams can be, for example, this one. I just changed that listing that I just showed you a moment ago to say a stream of doubles, scores, right? And then it's a stream of, and then I just put some double numbers here, right? And what I'm going to do is I'm going to reduce it to one double value. So I have scores dot reduce, and reduce receives 2 parameters on this side of the lambda, and then some operation that you do with those 2 parameters after, right? So I'm adding all the elements here. That's my reduction. And then this reduction actually returns a special kind of object, and it's an optional object, but it returns a special kind of object, and then I call get, and it will get me the double that resulted from this reduction, okay? So, and I can print it. So I can run this, and you can see that it actually prints 21.1, which is the sum of those numbers. So this is how you would reduce. A lot of people use the paradigm of map and reduce. So they will grab a lot of a source, right? And they will be filtering elements and then reducing them. And at the end get one value. So for example, if you want to compute an average, right, of a large data set. So that can be done. Now, just for reference, some of the very popular intermediate operations are these, right? So filter, map, limit, sorted, distinct, okay, of course. And then the terminal operations for each count, collect, reduce as well, right? And here in this table, if you want to save them, you can look at this in the Java API, but you can also see what they accept as parameters. With that, I hope that this has been a good introduction to streams. Find out more in the Java API. One last thing, because here I'm dealing with doubles, there are objects in the stream API such as double streams, int streams, and so on and so forth that have dedicated operations that are common to doubles and strings. So for example, for double stream, there's operations like get the average. There is a sum operation already, right? So I don't have to do it this way, and so on and so forth. So keep finding out about streams. They're a pretty cool way to manipulate objects in an efficient and very highly probability that you can parallelize the work way. Bye.